Imagine Alaska, stunning, remote, and brutally cold. It's a land where nature's beauty is matched only by its harshness, and where survival depends on ingenuity and resilience. Here, Eielson Air Force Base stands as a vital defense outpost, where reliable power is essential for survival and security. In these extreme conditions, energy isn't just a convenience. It's a lifeline for the people who serve and protect. For decades, Eielson has depended on an aging coal-fired plant. Reliable, but outdated. The plant has powered missions and kept the base running, but it's showing its age. It's like using a landline in a smartphone world. It works, but it's not efficient or clean. The world has moved on, and so must our energy solutions. Now the Air Force is turning to the future. Nuclear energy, but not the kind you're used to. They're embracing innovation to meet new challenges. Enter Oklo's Aurora Powerhouse, a nuclear micro-reactor, small, advanced, and designed for resilience. It's compact enough to fit where traditional reactors can't, yet powerful enough to make a real difference. This isn't science fiction, it's the next leap in energy. These micro-reactors are real, and they're ready to change the game. What's happening in Alaska could transform how we power military bases, cities, and even space missions. The ripple effects could reach far beyond these snowy mountains. We'll explore how these micro-reactors work, why they're a game changer, and what this means for all of us. The possibilities are bigger than you might think. It's about solving big problems with small, powerful solutions. These innovations could redefine what's possible for energy everywhere. The future of energy is unfolding right now, under the vast Alaskan sky. A new chapter is being written in the story of power and progress. Let's dive in and see how the science of the atom is reshaping our world. The secrets of the universe are fueling the next generation of energy. The story starts here, at the intersection of strategy, innovation, and the urgent need for clean power. Let's get started. The journey to a brighter, cleaner future begins now. When you think nuclear reactor, you probably picture massive plants with giant cooling towers. Micro-reactors are different. Think of them as the pickup trucks of nuclear power, small, portable, and simple. They use nuclear fission, splitting uranium atoms to release energy just like big reactors, but on a much smaller scale. The heat from fission is transferred via heat pipes to a turbine, generating electricity. The real innovation? Passive safety. These reactors cool themselves naturally, no pumps or human intervention needed. Micro-reactors are compact enough to be delivered by truck or plane, and can power a base, hospital, or data center for years. They're factory-built, delivered ready to go, and can operate independently for a decade or more. It's nuclear energy, reimagined for flexibility and resilience. Clean, reliable, and ready for the world's toughest environments. That's the micro-reactor revolution. Let's compare micro-reactors to traditional power sources. Fossil fuels like coal and diesel require constant deliveries and produce pollution, logistically tough and environmentally costly, especially in remote places. Renewables like solar and wind are clean but intermittent. In Alaska's long, dark winters, they're not enough without massive batteries. Micro-reactors offer the best of both, steady, reliable power like fossil fuels, but with virtually zero emissions. Their energy density is unmatched. A small amount of fuel powers a facility for years, no constant refueling needed. No long supply chains, no weather worries. Micro-reactors are not here to replace renewables, but to complement them, adding resilience and reliability to the clean energy mix. In challenging environments, energy security is non-negotiable. Micro-reactors deliver it cleanly and efficiently. They're a powerful new tool in our energy toolbox. Reliable, clean, and compact, perfect for the world's toughest energy challenges. That's why they matter. The future is about options, and micro-reactors are a game-changing one. Eielson Air Force Base relies on a steady stream of power to keep jets flying and systems online. For over 60 years, that power came from a coal plant, a workhorse, but now a liability. Burning coal means pollution and a vulnerable supply chain. 800 tons of coal delivered daily, over 100 miles of harsh terrain. Any disruption, weather, disaster, or attack could threaten the base's mission. The Air Force needed a 21st century solution: clean, resilient, on-site energy. Oklo's Aurora Powerhouse answers that call. A micro-reactor can run for years on a single fuel load, slashing logistical risks and emissions. It's not just an energy upgrade, it's a strategic leap forward. Eielson is moving from coal to nuclear, from vulnerability to resilience. The future of military energy starts here, clean, secure, and ready for anything. Meet the Aurora Powerhouse, a revolutionary fast reactor designed by Oklo to be efficient, safe, and sustainable, setting a new standard for clean energy in remote locations. Unlike traditional reactors, it uses fast-moving neutrons and can even recycle nuclear waste as fuel, turning yesterday's problem into today's valuable resource. This means less waste and more energy from the same material. Housed in a compact modern building, the Aurora reactor is small but mighty, producing up to 1.5 megawatts of reliable power, with ambitious plans to scale up and serve even larger communities in the future. It supplements the base's energy needs, boosting resilience and reducing reliance on coal, diesel, and the traditional power grid, especially in harsh and isolated environments. Safety is built in from the ground up. Aurora is walk-away safe, meaning it can automatically shut down and cool itself without any human intervention or external power sources, even in emergencies. If it overheats, the laws of physics take over. The reaction slows down and heat dissipates naturally, so there's no need for complex backup systems or constant monitoring. The reactor is completely sealed and autonomous, designed to run for over a decade before needing any refueling, making it ideal for remote or hard-to-reach locations. When the core is spent, it's simply swapped out and returned to Oklo for recycling or safe storage, ensuring responsible waste management. There's no on-site waste handling, no complex refueling process, and minimal disruption to the site or community. Oklo delivers clean, reliable power as a service, managing the entire life cycle from installation to decommissioning, so customers can focus on what matters most. It's a new way to think about nuclear, simple, safe, and sustainable, with a focus on protecting people and the planet for generations to come. The Aurora is a tiny titan, ready to power the future with innovation, reliability, and a commitment to clean energy. That's innovation in action. Oklo's journey began in 2013, when two ambitious MIT graduates came together with a bold vision to revolutionize the world of nuclear power by making it smaller, safer, and more accessible than ever before. Their dream was to create a new kind of energy company, one that could change how we think about nuclear technology. The company took its name from the Oklo Natural Nuclear Reactor in Gabon, Africa, a site where nature itself achieved a self-sustaining nuclear reaction 2 billion years ago. Inspired by this natural phenomenon, Oklo set out to harness advanced nuclear energy, aiming to make it practical, reliable, and available to communities everywhere. In 2019, the U.S. Air Force announced a search for clean, resilient energy solutions at Eielson Air Force Base in Alaska. For Oklo, this was the perfect opportunity to put their technology to the test in a real-world, high-stakes environment. By 2023, Oklo was officially selected to build and operate the Aurora Powerhouse at Eielson, a major milestone for both the company and the future of advanced nuclear energy. This project marked a turning point, showing that innovative nuclear solutions could move from concept to reality. But the road to innovation is rarely smooth. The Nuclear Regulatory Commission, or NRC, initially denied Oklo's license application, raising important safety questions and concerns that needed to be addressed before moving forward. Oklo responded with determination, working hand-in-hand with regulators, engineers, and safety experts to address every issue. They resubmitted their application, demonstrating a commitment to transparency and collaboration. This rigorous process highlights the nuclear industry's unwavering dedication to safety. There are no shortcuts, only the highest standards, strict oversight, and a culture that puts safety above all else. Years of careful design, exhaustive testing, and thorough review are required before any new reactor can go online, ensuring that every detail meets the strictest requirements. Oklo's persistence and resilience in the face of challenges prove their deep commitment to both safety and innovation, setting a new standard for the industry. The Eielson project is the culmination of a decade of relentless effort, vision, and teamwork, a real-world test for advanced nuclear technology that could shape the future of energy. This isn't just a theoretical breakthrough, it's a project that's being built right now, with real people and real progress on the ground. The future of energy is unfolding before our eyes, being built step by step, as Oklo leads the way toward a cleaner, more sustainable world. For the military, energy is mission-critical. Bases depend on secure, reliable power, but the civilian grid is vulnerable to cyber attacks, disasters, and outages. Energy resilience means a base can operate independently, no matter what happens outside the fence. Micro-reactors like Aurora provide 24/7 power, right on site, protected and secure. No more risky fuel convoys or dependence on fragile supply lines. Commanders can focus on their mission, confident the lights will stay on. The Department of Defense is the nation's largest energy user. Making its supply cleaner and more secure is a top priority. Eielson is the pilot. Success here could lead to micro-reactors at bases nationwide. It's about power, security, and readiness, anytime, anywhere. The military's energy future is resilient, clean, and independent. Eielson's micro-reactor is just the beginning. Imagine remote communities, from Alaska to Canada, powered by clean, reliable micro-reactors instead of diesel. Data centers, the backbone of our digital world, could run on dedicated nuclear power, clean and constant. Tech giants are already exploring this path. Beyond Earth, micro-reactors could power lunar or Martian bases, where solar isn't always an option. NASA is developing these technologies for future missions. Micro-reactors could also support heavy industry, disaster relief, hydrogen production, and water desalination. The applications are vast, energy, anywhere for anyone. Eielson is a preview of a world where clean, abundant power is always within reach. The future is small, nuclear, and transformative. The revolution has just begun. Oklo's Aurora at Eielson is more than a power plant. It's a turning point for America's energy and security. It shows the U.S. is ready to lead in next-generation nuclear technology. The project is a symbol of American innovation and a commitment to a cleaner, safer future. Public questions about safety and waste are important, and the NRC's oversight ensures the highest standards. Aurora's design addresses many concerns with passive safety and a sealed fuel cycle. This project supports national defense, fights climate change, and builds a new American industry. Success at Eielson could open a global market for micro-reactors. The story of Aurora is one of hope, progress, and the power of science. This small reactor in Alaska lights the way to a secure, sustainable future. It's a bold step, and the right one. The future is bright, and it's powered by innovation.